Welcome back. It's Wednesday, April 29th. This is the last lesson for the week. Beginning of the week on Monday, we talked about what climate is, an average, a 30 to 50-year average of things like temperature, precipitation that help define the plants and animals that can exist in a location. Yesterday, we looked at changing climate. Wisconsin's climate is not the same as it used to be. We showed how farming is impacted by that, fishing industry. We talked about forestry. There were some other awesome videos on that Climate Wisconsin website that I gave to you. Hopefully, you had a chance to watch some of those. And today we're going to look at a more global perspective on the changing climate. And I'm using two resources that I sent to you as well, along with this climate.nasa.gov, which is obviously NASA and collecting information associated with climate change that I'm going to share with you. And then another one that shows the 10 hottest years on record on planet Earth. So I'm going to start with this NASA website today. And in order to track climate change, NASA is looking at four different things: global temperature, which can be tracked back to the 1800s, the amount of carbon dioxide in the atmosphere, because scientists believe that carbon dioxide in the atmosphere traps heat. They don't believe it, they know it. And they're looking at the amount of carbon dioxide year after year after year that's in the atmosphere, and if that relates to the temperature at all. They're also looking at ice, the amount of ice in Greenland on the Greenland ice sheets, and the amount of ice in the Arctic. And I'll show you some stuff on that as well. So here we go. We are going to start with, let's start with a scary one: global temperature. All right, so I'm going to click on this, and hopefully my computer is going to load it. And there are a couple of things here that you can see. This line illustrates the average change in temperature on planet Earth over time. And you can see that from the 1880s, we were down a little bit, 1940, and since about 1960, we've had nothing but an upward trend in the average temperature on planet Earth. Now, that line is scary enough, but not nearly as scary as the kind of this map over here on the right. So what you can see is this map. This starts in 1884, and it shows, all right, if we average, what's the average temperature on planet Earth? And then the colors represent below that average or above that average by a certain number of degrees. So blues, darker blues, that means colder than average. Yellows are about average. Oranges and reds are above average temperature. So when you take the slider, and I'm going to go through this kind of slowly, but you can see a slight change. We have a few yellows and oranges, but not very many. Mostly blues, mostly still below average temperatures. And we get about halfway through this, and we're starting to get into the mid 1900s here. And you can see, especially in the Arctic areas, how temperature is increasing dramatically up into those oranges and reds up in the Arctic. And that's the thing about climate change and changing temperatures. And that is that temperatures are changing more drastically at the poles than they are at the equator. So the closer you are to the North Pole, the South Pole, the more dramatic change in temperature that people are seeing. So I'm going to keep going here, and you can see, we still have some blues and yellows, and it's still kind of below average here. That was just maybe just something weird that was happening in here for a few years, right? But now we skip forward towards 1980, and you can see that we've got some pretty serious oranges and reds, and those blues are almost all gone. And here is 2019. Oranges and reds almost everywhere. The reason that we can't use the term global warming is this blue spot right here, this blue spot, because in those very isolated locations, which you can see are almost all in water, um, they actually had slightly lower than average temperatures. But look at the rest of the planet. Everywhere that humans are located, especially look at Alaska up here. Many days it was warmer in Alaska than it was even in the continental US in 2019. Russia, Asia, Europe, all across the North Pole area, um, and in the South Pole, we've got tremendously warmer temperatures than we had in the past. I'm going to zoom. This is what it was in 1884. Lots of blues, very few reds and oranges, all the way to today. Almost the exact opposite. Way more reds and oranges and yellows than we have blues. So, this is a great illustration of how temperatures have changed over time on planet Earth, and not necessarily for the better. Now, I'm going to show you a couple of other graphics. This one is on carbon dioxide. And as I told you, scientists know that carbon dioxide traps heat in the atmosphere. The more carbon dioxide that's there, kind of the thicker the blanket is, that's going to trap more heat. And when we look at this line, and this is only going back maybe 20 years, and you can see that maybe in 2005, there were less than 380 parts per million of carbon dioxide in the atmosphere, all the way through, and now we're getting into your lifetime here, 2006 and 7, still maybe 382, all the way through to today in 2019. In February of 2020, we're up to 413 parts per million of carbon dioxide. There are about 600,000 years worth of history that scientists are able to collect carbon dioxide levels. They drill down and get these ice cores, and the bubbles that are trapped inside them are actually parts of the atmosphere. It's air, right? And so they can test the amount of carbon dioxide in them. In no time in the last 650,000 years has carbon dioxide gone above 350 parts per million until the mid 1900s. And since then, vehicles, factories, deforestation, the burning of trees, all of that has led to an increased amount of carbon dioxide in the atmosphere. So when we look at this number, we can see an increase in carbon dioxide, and we looked at our global temperatures, and you can see that those two things match. The more carbon dioxide that's in the atmosphere, the higher the temperature goes. All right. So clearly, carbon dioxide in the atmosphere is something that's important for us to try to figure out how we're going to lower that. Now, there's some other things that they've measured. This is ice in the Arctic, and it's going to take a second to load up. But here you can see that this is a picture of the North Pole taken by satellites, and this is 1979. And you can see this line shows you how many million square kilometers of ice there is in the Arctic. And again, we get to about your lifetime here in 2006. And from there, we've got some ups and downs. But for the most part, the trend is straight down. 4.32 million in 2018. When you were born, it had about 5.86 million square kilometers. So it's going down significantly. The picture illustrates that much better. And again, these are satellite pictures that are taken above the North Pole. And I want you to watch what happens to the amount of ice up here at the North Pole. And what you can see is that there is significantly less now than there used to be. Significantly less ice. The thing about that is this: ice reflects sunlight. So when the sunlight hits the ice, it bounces back up into space. Water absorbs sunlight. So the more water there is, the more sunlight that's absorbed in that particular area. It warms the water and helps to melt the ice. So this process is going to be very difficult to slow down or stop because the less ice, the warmer the water. The warmer the water, the less ice. And it's kind of a vicious circle. All right. The last one that I will show you are the ice sheets in Greenland and Antarctica. And what you can see here is how many gigatons, and that's a lot, like gigas, that's a big number, tons of ice per year these ice sheets are losing. In Antarctica, 146.1 gigatons per year less. And you can see 2020 is almost off the charts with the amount of ice still remaining in Antarctica. Greenland, which you can see is a very similar thing, 281 gigatons per year that loses. So when we lose that freshwater ice off of the land or off of Antarctica, it goes into the oceans, it dilutes the oceans, lowers the amount of salt content in there, and also, again, less ice to bounce that solar radiation back up into space. These are kind of our air conditioners that help to keep the planet cool, and we're losing ice in those particular areas. All right, so these are the things that NASA is tracking: the carbon dioxide levels, the temperatures, excuse me, over the years, and the ice sheets and glaciers. This is a scary statistic, and I'm going to show you something that's a different website. 19 of the 20 warmest years on record have occurred since 2001. 19 of the 20 warmest years on record have occurred in 2001. Keep in mind, these are global temperatures. Just because we have a cooler summer here in Wisconsin, it factors into the average, but that doesn't mean that the planet isn't warming. We have to think globally when we look at these particular data sets. All right. And I'm going to show you here in these 10 hottest global years. This is not the 20 hottest, these are the 10 hottest. I want you to look at the last, in your lifetime. How many of the 10 hottest years on record have occurred in your lifetime? And we'll work our way backwards. 2018, it's on the list of the 10 hottest. By the way, 2019 will be on this list as well. It just hasn't had a chance to be all the data to be uploaded yet. But here's 2018, 2017, 2016, 2015, 2014, 2013. So the last 7 years are all in the hottest 10 years ever on planet Earth since we've been able to measure them, right? This is a real issue that needs to be looked at. We need solutions, we need engineers, we need thinkers, we need people to help solve this global problem. So hopefully I've given you enough evidence so that you can see, yes, carbon dioxide is increasing. Yes, temperatures are increasing over time. Yes, we're losing ice. Yes, we've got the hottest years on record all recently, and this is a real issue. All right. So with that said, I challenge you to do your own research, do your own thinking about how we can help solve this problem, because we're going to need young people like you to help solve it. Because clearly, old people like me, we haven't solved it. All right. So with that said, don't forget to take the short quiz for today. This is the last one for the week. Make sure that they're all in, preferably by tomorrow. You do have till Friday at noon, but preferably by Thursday night so I can get those in the grade book and you can get your passing grade for the week. If you need me, email me, Google Hangout, Google Meet. You know how to get a hold of me. Just make sure that you do that if you need my help. All right. So with that said, I look forward to hearing from you. Look forward to seeing your quiz results, and I will talk to you next week.